Hey class, so we're looking at equations with trig ratios. So what we'll be doing here is we'll be looking for the angles that make these equations true. All right, so first step here is I want to go ahead and get tangent by itself. So I'll start by subtracting square root of 3 from both sides. And now we can find the angle. So to do that, it's important to know that the tangent is the sine divided by the cosine. And then to remember this part of our unit circle here. So now to get negative square root of 3, we need to use one of these points, sine being the y value, cosine is the x value. So to do that, we could either have negative square root of 3 over 2 over 1/2, or this other fraction here. All right, so that means we're going to be using this pair here. So this would be pi over 3 is the angle. In order to make it negative, we could go to 2 pi over 3. Right, so I'll make the cosine negative, so giving us this here. Or 5 pi over 3. So here, the cosine is positive and the sine is negative. All right, so that gives us our first two angles of 2 pi over 3 and 5 pi over 3. To get these other two angles, notice that we're looking at angles between 0 and 4 pi. So that gives us a whole nother rotation around the circle. So what I'm doing then is adding 2 pi to each of these angles, or 6 pi over 3 to each of those angles. Okay, so with our next example, we're starting off the same. We want to get, in this case, the cosine by itself. Okay, doing that, I get negative 1 over the square root of 2, or negative square root of 2 over 2. So if I have a square root of 2 over 2, we know that's going to be something with a pi over 4. And we know it's negative, so it's going to be either here or here, because over here the x value is negative. So these are the possible angles for our cosine. So here I'm using a set notation here just to group it all together so I don't have to write out a couple different equations. But here this will be 1, 2, 3 pi over 4, 5 pi over 4. So those are the possible angles there. And then to get x, I have x minus 3 pi over 4, so I'd add 3 pi over 4 to each of these. Okay, this one really is fairly similar to the last couple examples. I'll try to not make this too long, so you can take a look at that if you'd like. Okay, this one I think is kind of interesting. Here I'm dividing both sides by the sine of theta, and this is actually the cotangent ratio. So I'm looking at cosine divided by sine in this case equals square root of 3. So in order to get that, I could do square root of 3 over 2 over 1/2, or this alternate fraction here. Okay, so where I get square root of 3 over 2 for cosine and 1/2 for sine is right here at pi over 6. If I want them both negative, can go over here. This would be 6 pi over 6, 7 pi over 6. So I would have those two angles. Right, and again, some of this is pretty similar to the other things we talked about, so I won't say too much more about it. You can feel free to ask me questions later. But one of the things I want to point out here is to make this problem a little bit simpler. Something I can do is go ahead and do a substitution. So if I say the sine of theta is equal to x, I can substitute in x wherever I had sine there, and now it's a quadratic that I can factor. and I can solve for my x values that way. Substituting again, for sine, I can solve for the angles. Here, I didn't do the substitution because it wasn't too bad just to factor out sine of x, but doing a substitution here could help as well. All right, so didn't want to make the video too long, so if you have any questions on any of this, please let me know. And all right, thanks.